Hello guys, welcome back to my YouTube channel. Today I am going to solve day 31 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I am going to solve problem number 1105, feeding bookcase shelves. Okay, so I am going to solve this problem using top-down approach first, and then later on I am going to solve this problem using bottom-up approach. Okay, so first let's read the problem statement. So in this problem you are given an array of books where books of I is equal to thickness and height. Okay, so width of the book is given to us and the height of book is given to us. Okay, you are also given an integer shelf width. Okay, so we have to put the books over the shelves now. So we have given the total width of this shelf. Okay, we want to place these books in order, okay, onto bookcase shelves that have a total width shelf width. Okay, so we have to maintain the order, okay, whatever the order given to us. We choose some of the books to place on this shelf such that the sum of their thickness or width is less than or equal to shelf width. Okay, so let's say I want to place, this is my book 1 width and then this is my book 2 width. Okay, so after that, if my book 3 width is greater, okay, here total width, see the total width of all 3 books. Okay, so if by adding book 3 in the shelf and my width becomes greater than the overall width of my shelf, then I can't place this here. Okay, this is the meaning of this line. Okay, so we choose some of the books to place on this shelf such that the sum of their thickness is less than or equal to the shelf width. Okay, then build another level of the shelf of the bookcase so that the total height of the bookcase has increased by the maximum height of the books we just put down. Okay, so this is first shelf. Okay, so in my first shelf, let's say the height of this book is 2. Okay, and height of this first book is nothing but 1. Okay, is 1, and then after that I can't place this book 3 because the total width is increased, right? So what I'm going to do, I'm going to put, let's say, this book here, okay, in a new shelf. Okay, so here for this shelf, total height that I will get is the max height of any book, okay, in this shelf. So max height of any book in this shelf is nothing but 2, right? So I'm going to get the height 2 here for this particular shelf. Okay, for this particular shelf. Okay, so this is important line. Okay, so then build another level of the shelf of the bookcase so that the total height of the bookcase has increased by the maximum height of the books we just put down. We repeat this process until there are no more books to place. Okay, and note that at each step of the above process, the order of the books we place is the same order as the given sequence of books. Okay, so this is important line. So for example, if we have an ordered list of 5 books, we might place the first and second book onto the first shelf, the third book onto the second shelf, and the fourth and fifth book on the last shelf. And in the end, we have to return the minimum possible height that the total bookshelf can be after placing shelves in this manner. Okay, so this is example given to us, right? Example number 1. So these are the books. Okay, so say here this book, let's say this is my book A, this is my book B, this is my book C, this is my book D, this is my book E, this is book F, okay, and this is book G. Okay, so here see this A book, this is nothing but my width, right? Or this is nothing but my height. Okay, so here I am placing this book A here. Okay, then 2 3, this book, okay, so width is 2 and height is 3, so I am placing this book B here. I am placing my book C here, then I am placing my book D here, E here, F here, and then after that I am placing my book G here. Okay, so in this way what is the total height that I am getting? Okay, so for this 7th book, okay, G number book, okay, the height is 2 now, So here let me write 2. 2 is the max size here. What is the max size here of the book? 2 and 3 both have same size, so let's see the height of book B and C. So both have same C 3 now. So here I am just going to write 3. Okay, this is 3. And this book A height is 1. Okay, this is 1. So here total height, what is the total height I am getting? 1 plus 3 plus 2 is nothing but 6. Okay, the sum of the heights of the 3 shelves is 1 plus 3 plus 2, 6. Okay, so here can we solve this problem using greedy approach? Let's see. So this is the example, right? So first I have to place this book. Okay, so let's say I have placed this book, and total width I have is 4, right? So total width is 4. Okay, so I place this book here. So now my remaining width is 3. Okay, so I can place this book. Okay, so let's place this book here. So I have placed this book. Okay, this is book number A, this is book number B. Okay, good. So after placing both these books, so now my remaining width is just 1. Okay, so can I place this book here? No, I can't place this book here now, because total shelf width is just 4. Okay, so here 1 plus 2 3, and here it will become 5, and 5 is greater than 4, so I can't place. So I have for C I have to create a new shelf. Okay, and let's add this book here, C. Okay, so here I have added C. Now what is the remaining width? So 2 I have covered. Now remaining width is 4. Okay, so remaining is 4 minus 2, sorry. So that simply means 2. So here I can place D and E both. Okay, so let's place D and E here. So D, and then I can place E here. Okay, so here C, D, E both are in one shelf. I can place, right? I can place because total bit C 2 plus 1 3 plus 1 4. Okay, so I am good. So what is the max book in this shelf? C, which is having height 3. Okay, so here in this shelf max height is 3. In this shelf my max height is 3. Okay, now I have to place these two books as well. 1 1. Okay, so let's place it here. 1 1. Okay, I have placed it here in the next shelf. And 1 2. Okay, I can place it here as well, right? 1 2 I have placed here. So what is the max length I am getting here? So this is nothing but my book number F G. Okay, F, and this is G. Okay, so here what is the max length? So I am getting 2. Okay, so what is the output I am getting here now then? 3 plus 3 6 plus 2 8, and 8 is not my output, right? We have to return the minimum possible height. That is why greedy will fail here. Okay, so I hope that this answers your first question, why we can't apply greedy approach here. Okay, because, and now since our greedy fails here, so that simply means that we have options at every level. Okay, so here if I place this book A, then after that I have option if I want to place this B or not. Okay, so I have options now, whether I want to keep this book here or whether I want to skip this book here. So now you know where I'm moving. I am moving towards nothing but my top down approach. Okay, using recursion and memoization, right? So I am moving towards recursion and memoization. Okay, so now let's try to solve this problem using recursion and memoization. Okay, so let me just take this example. Okay, only. So here first book is 1 by 1. Okay, so 1 by 1. Okay, so this is the first book. Okay, so let's say if I keep this book, okay, and if I skip this book. Okay, so if I keep this book, then my total height will become 1, and my remaining width, okay, remaining width RW, so total width is 4, right? And then my remaining width will become 3 on this particular shelf. Okay, and if I skip this book, then my height will remain 0, and my remaining width is going to be 4 only. Okay, okay, so this is for book A. Now I move to book B. Okay, 2 by 3. Okay, so if I want to keep this 2 by 3, or if I want to skip this 2 by 3. Okay, I have two options again. So can I keep this 2 by 3 here in 1 by 1? Remaining width is 3 and here 2. So yes, I can keep it. Okay, so if I keep this book, then my remaining width will become nothing but 1. Okay, this is 1 plus 2 3, total width 4 minus 1 is 4 minus 3 is equal to 1. Okay, remaining width will become 1, and max height will become now, so max height here 2. Okay, we are keeping the books in same shelf now. This is same shelf. Okay, keep. keep, and then keep. Okay, same shelf. So first I place this book, then after that if I keep next one. Okay, so here if I keep this, if I skip this, so here if I skip this, then my remaining bits will remain 3 only, and my height will remain 1 only. Okay, if I don't add. Okay, so every level I have 2 options now. So this is what we need to do. Okay, this is how we are going to solve this problem. I need to decide whether I want to keep this book at this level or whether I want to skip this book at this level. Okay, then I have multiple answers. Okay, in the end I am just going to return the best answer. Okay, so now first let me write the code, and while writing the code I am going to explain step by step, okay, whatever I am going to do. So let's move to the coding part. Only then you guys will get more clear understanding, okay, of what's happening here. Okay, so now first thing that we have to do here, let's calculate the length of these books. Okay, so here or you can do one thing here in the outside only. Let's create one variable private int, and let's name it as n. This is nothing for my number of books. Okay, so here let me add the comment for my number of books. Then after that let's create one variable private int width. Okay, private int and width. Okay, so I am creating this for, this is nothing but for shelf width. Okay, what is the width of my shelf? Okay, so let me write that as well. Okay, and we have to do memoization as well. Okay, so let's do that later on. First let's try to solve this without memoization. Okay, it will definitely give time limit exceed error, but let's do that. Okay, so now after that inside this in n, let me store the total length. Okay, total size of this array books dot length, and then let me assign the value of this shelf width to this width. Okay, so here shelf width, and then after that just I'm going to return. Okay, here I'm just going to call one method. Let's name this method solve, and inside this solve method I am going to pass my books array. Okay, and then after this books array I am going to pass the value, okay, from where I'm going to start. Okay, so here let's write 0 initially. Then after that I am going to add the remaining width. Okay, so in the remaining width I can simply add what, my shelf width. Okay, so here I am just going to add my shelf width. Okay, remaining width is nothing but my shelf width, whatever the value. Okay, so here let's write that. Okay, and then after that here just pass this 0. Okay, and this 0 is nothing but the max height until now. Okay, so until now we haven't kept any book, right? So that is why my max height is 0, right? Okay, so I hope that this is clear. So I am going to call this method directly here from here. Okay, so now let's write this. Okay, so now you guys will get more clear idea, okay, what is happening here. So now private int solve, and inside this let's write all these things now. First we are calling this books. Okay, so let me just copy paste this, then int I. Okay, then give my int remaining width. Okay, whatever the remaining width that I have. So here I am creating one variable remaining width, and then after that max height, and inside this we are going to check for the base case. Okay, if we have considered all books. Okay, so in the end we have to just return the max height, whatever the max height that we are going to get. So here if the value of I becomes greater than or equal to n, then in that case I'm just going to simply return the max height. Okay, initially my max height is 0. Okay, and my I value is 0 as of now, but I am going to propagate, okay, over all the books one by one. Okay, so now inside this in my array, okay, this is my array, right? So here this value is nothing but width, this value is nothing but height. Okay, so I'm just going to write the same thing here. Okay, so here int book width is equal to my array name books of I 0, and then after that let's write book height is equal to books of I and 1, right? Okay, right. And once this is done, now we have two options, right? If we want to keep it or skip it. Okay, so let's give the value. Okay, both int keep and skip. Let me give the max value. Okay, max value of whatever the max value if we get. Okay, so integer dot max value. Okay, here actually in keep and skip we are just storing the heights now. So here I am just giving the max height first, because in the end we just need to return the minimum height now. So that is why I am just giving max height initially. Okay, so here just write max underscore value, and let me just copy paste this same thing here. Okay, so now you have two options, right? So first option 1 is keep the book on the current shelf. Keep the book on the current shelf if it fits. Okay, so only then we can place the book now, right? So here inside this I am just going to run one if condition and going to check the width. Okay, so if book width, okay, if the book width is less than equal to my remaining width, okay, only in that case I can put the book, right? So here that's it. Okay, so in that case let's try to keep the book. Okay, so here I'm just going to write keep is equal to, and I'm going to call this method, okay, this solve method for now. Okay, so if I keep the book, then let's see what will happen. Okay, so in the keep method I am passing my books array. Now my I is going to move to the next position. Okay, initially I is 0 now, so now my I is going to move to the next index. Okay, and then but about my shelf width, so shelf width will be decreased now. So how we are going to calculate the decreased shelf width? So here what I have to write, I have to write my remaining width minus my book width, right? So this is going to give me the now remaining value. Okay, remaining width minus book width. Okay, so this is done, and after that here I have to update the height as well. Okay, so height is going to be the max value. Okay, so here this is the max book that is placed in the current shelf. Okay, this shelf number 3, let's say. So my max height is according to this book now, having the max height. So that is why inside this I am going to write math.max, and here by my max height, whatever the max height that I have, comma book height. Okay, whatever the value that is max, I am just going to return that. Okay, so this is for keeping the book. Okay, so now let's move to my option number 2. Okay, so now let's move to my option number 2. Let me write the comment as well. Option 2, skip to the next shelf. Skip to the next shelf. Okay, so now if this is the case, then just write skip, and now we are going to call this method solve, and inside this solve I am just going to pass my books, and definitely we are going to move to the next index. Okay, and since we are skipping now, so my width, what is going to be my width? Okay, so here inside this, but I have to write, so what is the total width that I have here? So this is width is equal to shelf width. Okay, I have signed. So here if I am skipping, okay, this is the width minus, and after that what I'm going to pass, I'm going to pass book width. Okay, so what is my book width? This one. Okay, and then after that here my height will remain same now, so here book height. Okay, so see here why I am writing this one. Okay, why I am writing width here, okay, and why I am writing remaining width here. Okay, so since here we are moving to the next shelf now, so definitely in next shelf I will get the complete shelf, and I have stored the size here of the complete shelf. That is why I am writing it here. And since we are moving to the next shelf, okay, that simply means that we are keeping the book in the next shelf. That is why I am writing here book width. Okay, that is why I am subtracting. So this is nothing but my remaining width in the next shelf. Okay, and this is nothing but the remaining bits in my current shelf. Okay, so I hope that this is clear. Okay, now once this is done, then in the end I am just going to return from here math.min of keep, yeah, skip, right, keep or skip, that's it. And here one more thing, this is the height that we are calculating in the keep level. Okay, and in the skip level we are moving to the next shelf. Okay, so for previous shelf also we need to include the height, right? Since we are skipping to the next shelf, so let's take the height of my previous shelf. So what I'm going to do here, I'm going to write max height here, whatever the value of max height that I have. Okay, and then I'm going to call this. Okay, so now let's try to run it and see. So see, both the test cases has been accepted, right? Okay, both the test cases has been accepted. Now if I submit it, let's see what is the error that I'm going to get. So see, only 7 out of 20 test cases passed, and we are getting this error, time limit exceeded, right? Let's use Memoization here. Okay, site is very big, right? 1000 is given to us. Okay, so we can't check again and again for 1000. Okay, again and again. So what I'm going to do, I'm going to do the Memoization here. Okay, so here inside this I am going to create one 2D Memoization array. Okay, so private int memo. Okay, and here this is for Memoization array, so here let's write the comment Memoization array. Okay, now inside this, initially let's do one thing here. Initially let's store the values, all the values in this Memoization array as negative -1. Okay, so here let's initialize it first now. So new int, and inside this we are just going to pass size is 1000 given to us, right? So here I'm going to write 1001. Okay, 01. This is the size given to us, right? Let's see. Include it is inclusive, right? Less than equal to 1000. Okay, so that's why we need to write it like this. Okay, now after that let's iterate over all the rows one by one. In my memo, and I'm just going to fill arrays dot fill, and here pick that particular row and fill all the values as -1. Okay, this is done. That's it. Okay, so this is the common thing that we do for the Memoization. Okay, every time we create one Memoization array, we store the values in that Memoization array as -1. Okay, and whatever the results that I'm going to get, I'm going to store that here somewhere. Okay, so here what I'm going to do here, just I'm going to write memo of I. Okay, so these are the values that are changing every time. Okay, so here I and remaining width. Okay, I am going to store this here. Okay, and here one more thing that we need to check. So here let's check it here only. So here we are going to check if we have already computed that particular value, right? Computed this subproblem. So here just what I'm going to do here, I'm just going to run one if condition. If memo of this one is not equal to -1, that simply means that I have already got some answer here. so I don't need to check this particular again problem again. Okay, so return again, that's it. Okay, and yeah, that's all. Let's try to run it and see if there are any code issues. So all the test cases has been accepted. Now let's try to submit it, and let's hope that all the test cases been accepted. Yeah, yes. Okay, so see, our solution is accepted, right? So this is nothing but my top down approach, okay, in which we are using a recursion and memoization, right? So now after this I'm going to solve this problem using bottom up approach, that is nothing but using dynamic programming. Okay, so now let's move to the code for the bottom up approach. Okay, so let me just revert all the changes. Okay, so I hope that you guys are clear with this one. Okay, so now code is going to be very small for this bottom up approach. Okay, so I'm going to do the same things here. Okay, so first let's calculate the length of my books array. Okay, so here I'm going to write int n is equal to books dot length, and then after that I'm going to create one dp array. Okay, and here just going to initialize, and here I'm going to write n plus 1. Okay, because 1000 is already there. Okay, until 1000. So now since we are solving little sub problems, then we get the result. Okay, in this bottom approach, so initially dp of 0 value, let's see, in the starting there are no books now, so that is why I'm going to add 0 here. Okay, no books, simple comment, no books, no height, obviously, right? So this is the case. Now I'm going to iterate over my books array one by one. Okay, so for int I is equal to 1, I is less than n, less than equal to n, and I plus plus. Okay, inside this initially let's take my width as 0, and my max height is also going to be 0 initially. Okay, max height is equal to 0 only. Now after that in dp of I, okay, write down dp of 1, that simply means dp of 1. Okay, I is 1 now, so here I am passing integer dot max value, integer dot max underscore value. Okay, and then after that I am going to run one more loop for int j is equal to I, j is greater than 0, and j minus minus. Okay, so this is j loop, and j is going to run until my I. Okay, so here what I'm going to do first, I'm going to check the width. Okay, so in my width, okay, in my width I'm going to add the size of my book, which is at j minus 1. Okay, that simply means previous book. Okay, so not my current, my previous book. Okay, so here I'm just going to take the width of this one. Okay, I'm just going to add the width. Okay, now if width, okay, if the width is greater than my shelf width, okay, don't worry, I'm going to explain this in the end. Okay, after writing the code, just understand side by side. Okay, if width becomes greater than my shelf width, then I'm just going to simply break that, and in the max height, okay, and in the max height I'm going to update it as math dot max of my max height. Okay, whatever the max height, that value that I have until now, and in this I'm just going to pass books of j minus 1, and my height is at index 1, so that is why I'm going to write 1 here, and here I have to just update my dp of I value. Okay, whatever the dp of I value that I'm going to get. Okay, so this is nothing but math dot min, and I will get this value from this particular dp of I, and here previous dp of j minus 1 plus max height. Okay, and in the end I'm just going to return dp of n. Okay, so that's the code for this approach. Okay, dynamic programming. Okay, return dp of n. Okay, so now let me run the code first. So let's fix that. Books now. So here I have to write books. Let me go to the code. Here it should be books. So the test cases has been accepted. Last time my runtime 13 milliseconds. Okay, so now let's run it again. Let's submit the code. Now runtime is just 1 millisecond. Okay, so I hope that you guys are clear with this bottom-up approach. Okay, so now let's see what is happening here. Okay, so now let me just copy this code. Okay, and let me select the example that we have here. Okay, this is the example, so let me just copy paste it. And the shelf width that we are having is 4. Okay, so here let me write shelf width is 4. Okay, so initially my I is 1. Okay, here I is 1. Okay, and here width is 0 and max height is 0. Okay, and dp of 0 value is 0. Okay, and dp of 1 value is max value of integer. Then my j is I, and j is greater than 0 and j minus minus. Okay, so here initially when my I is equal to 1, then my j, I am running this j loop, and now let's see inside this j loop. Okay, so here first thing in this width, what I'm doing, so this is my width. Okay, so width is equal to width, initially width is 0. Okay, so let's see, this is one shelf. Okay, 0, and in this I am adding books of j minus 1. Okay, j minus 1. Okay, j is nothing but I. Okay, so 1 minus 1 is 0. Books of 0 by 0. So books of 0 by 0 is nothing but this one. Okay, so that simply means that this book, I am talking about this book. Okay, so here this is the width. Okay, total width is 1, and this width is greater than my shelf width. My shelf width is 4. No, so I am not breaking this. Okay, now I am calculating the max height that I am going to get here. So my max height is nothing but max of max height. Initially it is 0, and here what is the height that I am getting here? So height of this book is 1. Okay, so I am going to get the height as 1 here. Okay, so here I am updating my max height is equal to 1, and my okay, so I am just talking about this first book. Okay, one by one. This is a book. Okay, so this is done. Then dp of 1 I am going to update. So dp of 1 is equal to minimum of, so this is value is infinity, right? So here dp of j minus 1. So dp of 0 is 0 plus max height. So max height is 1. Okay, so dp of 1 value is 1 now. dp of 0 value is 0 and dp of 1 value is 1. Okay, so I hope that this is clear. Okay, now after that, once this is done, my I will become 2. Okay, so here let me just erase it. Okay, so now my I will become 2. Okay, so when my I is equal to 2, okay, so here again my width is again 0, max height is equal to 0, and dp of 2 is equal to integer dot max value. Okay, so after that, inside this I am just going to run this j loop. So now my j is going to run from 2, 1 and then 0. Okay, last time my j was 1, so it was going for 1, and then after that it was going for 0. Okay, total 2 cases, right? Okay, 0 for 0 it will not run, sorry, for 0 it will not run. Okay, since I have given this condition, j is greater than 0. Okay, so for last time when my I was 1, my j run for just 1. Now my I is equal to 2, then my j is going to run for 2 and then 1. Okay, so now let's see when my j is equal to 2 first. Okay, so now my width will become here. So here width is nothing but width value is 0 initially. Okay, width value is 0. So 0 plus books of this value is nothing but j is equal to 2, 2 minus 1, 1. Okay, 1 by 0, 1 by 0, that simply means that I am talking about this book. Okay, 1 b book. Okay, so here what is the width here? 2. Okay, so in width I am adding just 2. Okay, so this width is greater than my shelf width? No. Okay, now I'm checking for the max height. So max height is nothing but max height. Initially my max height is 0, and here this max height is 3. Okay, so now my max height will become 3. Okay, now I'm going to operate this dp of 2. Okay, so dp of 2 is equal to math.min of dp of 1. dp of 1 value is 1. Okay, math.min of dp of 2. So dp of 2 value is 2 or infinity. Okay, this is integer.max value, no? dp of 2. And here dp of j minus 1 simply means j is 2 minus 1 dp of 1. So dp of 1 value is 1 here. Okay, this value is 1, this value is infinity, and 1 plus max height. So what is the max height that I am getting here? 4. The max height is 3, so 1 plus 3 total I am getting 4. So dp of 1 value, right, dp of 2 value right now is 4, 0, 1, and here I am getting 4. Okay, okay, this is done. Then after that, now for j is equal to 1 it is going to run. Okay, for j is equal to 1. Okay, so this is for j is equal to, now j for 1. So now my width will become width. I have to check the width, right? So width is equal to width plus books of j minus 1, 0. Okay, so j is 1 minus 0, 0. Okay, so if I keep these two books in the same place, okay, so I have checked if I keep this book A here, then after that I have checked if I keep this book B here, and now I am checking if I keep both the books. Okay, so this is the use of this bottom up approach. Okay, so little by little we are proceeding. Okay, so from small cases we are checking for the bigger case. Okay, so I have checked this is possible, I have checked this is possible. Now check if we can keep both. Okay, so now here my width will become these two books, total width of these two books. Okay, so here let's use the code. Okay, otherwise I will simply explain the diagram using this example, but let's see. Okay, so now previously my width was 2, now I have to add this width. So 2 plus 1, total width will become 3. Okay, so now my width become 3. Okay, this is for my j is equal to 1, width become 3, and this 3 is greater than my shelf width. No, not greater than shelf width. I'm not breaking. So max height is equal to, previous time my max height is 3, and now my books of j minus 1. Okay, so it simply means 0, 1, 1. Okay, so what is the max height till now? 3 only. Okay, so I have told you now, if I am placing two books in the same shelf, one is having height 1, one is having height 3, then I have to take the maximum. Na? That is why I am storing 3 here. Then I have to operate my dp of 2 again. So now what is the value of my dp of 2? Okay, so now the value of my dp of 2 is equal to math.min of dp of 2. dp of 2 last time is 4. Okay, and now here I have to take the minimum min. Okay, dp of 0, this j is right now, what is the value of j? 1. 1 minus 1 is 0. Okay, so dp of 0 is 0 only. So here 0 plus max height that I am getting. So max height that I am getting here, here, see here, what is the max height I am getting here? 3 now. So here what is the minimum? Minimum between these two is 3. Okay, so now my dp2 is updated to 3. Okay, dp2 is updated to 3. Okay, so now let's suppose, okay, let's suppose if this is the case. Okay, there are no other values. Okay, if this is the case only, if this is the just case, this is the only case. Okay, so now let me draw. If I okay, if I place, this is shelf number 1. Okay, if I place this book A here, then total height is 1. Okay, this is my shelf 2. If I place my next book here, which is having height 3, right? So now if I do this scenario, then total height that I am getting is 4. Now if I place both the books here, A and this is B. Okay, A is having a height 1 and B is having height 3. Then total height that I am getting here is 3, right? Total height I am getting is 3 here. Okay, so in the end I am just returning dp of n now, dp of n, and I am saying here I don't have these cases. Okay, so I have to just return dp of n. Okay, so in that case, see here, this is my DP array and last value is showing 3 and 3 is correct answer, right? In 3 only I am getting the max height, right? So I hope that you guys are clear. Okay, so you can proceed further with these cases. Okay, but if these are just cases, then I have explained. Okay, until here I have explained, and in the end we are getting the best answer, we are getting the max answer, we are going to get the best answer every time. Okay, so I hope that you guys are able to understand this problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you.